Hello and welcome. So last time we created our own component, mainly this script called test script, which has this string parameter here, which we can edit. And it takes this string and place it and debugs it here, each frame of the game. We can also get references to these other components. So back in our script, you can see that this variable is of type string, and it's called name. We can call it whatever we want. It's not you don't need to call your variable name. You can call it pretty much anything. But if you want it to be of type string, then you have to type string correctly, all lowercase like this. And now I'm going to show you how we can access different components. For example, this box color component, I can say, just like we created a string variable, we can create a box collider, and we can call it box collider like that, just short for box collider. And notice that this is differently color coded. Well, that's because it's not kind of a variable, but it's more a reference to the component. And now this box collider, we could have created a box collider 2D, which you might have noticed, but since this is a 3D game, and in 3D games you have the basic box collider, we're using that. If you're making a 2D game, you can go ahead and create a box collider 2D reference. Now when the game starts, we need to get the actual component, because like this, now we just referenced it, we didn't get the component, because now in here, in our, let me just clear the console, in our test script component we have some value for the name parameter. Let's go ahead and then start method say box collision, and it's going to be equal, and we want to say get component. So we're getting the component of this game object, and the component that we want to get is going to be box collider, and then we put the brackets here and semicolon to end the line. Now we have, when the game starts, we will grab the box collider component, this one, and we will be able to access it from this variable. So here in void update, I can say, actually, let's do it in start. So when the game starts, I will grab the reference to the box collider, and what I say is box collider dot. Now this allows me to change the values from the component. So I can say box collider dot is trigger, and I can set this to be false. So now, if you have noticed, let me just clear these warnings. If you've noticed, isTrigger is currently set to true, and that's why our cube was falling through the ground. And now if I play, we should grab a reference to the box collider and disable isTrigger. So before we do that, I will quickly click on cube 1 and just change the name of this game object to ground, so it's easier for us to follow this. And let me as well move the camera a bit up. There we go. Now if I run the game, the cube falls down, which means that the box collider isTrigger component did in fact turn off. Okay, so whoops, on the cube. Now it is set back to true, to turn down, but if we play the game, it will turn off as soon as the game starts. So there you have it. That is a way how you can reference these other components. We can also reference basically any of these components, but I won't go into too many details about this currently, because I don't want to move off track. I want to continue with our kind of, we did some debugging. We wrote hello world, but let me just delete this. But the problem with this is, just say here, hello world. The problem with this is that this is in our developer console, debugged here. The player doesn't know we said hello world to him, so we're going to go ahead and do that now. To display messages to the player, any kind of, well, yeah, messages, user interface, we use a UI called user interface. So under hierarchy, click create, go to UI, and we want to create text for now. So let's go ahead and click text. And here we can see our text. And now if I go to my scene view, and if I zoom out, you can see that we have this line here. And if I double click the canvas, there you can see this is our canvas. So basically this is the viewport of the player. So whatever you write in here will be visible to the player on his screen. So now the text here, we can set the anchors to be maybe up. These are just some presets where you want the text to be positioned. So now if I set position Y to be 0, you can see the text went up. But let's just drag it down, minus 50. There it is. And also it changed the free aspect to 16 by 9. 16 by 9 is the most commonly used aspect ratio for games. And let's just move on the X, maybe 45. There we go. We can change the font, but I currently don't have any fonts imported into my game, so I'll have to use Arial. We can increase the font size here, 16. We can change the line spacing, and then here we can edit our text. So currently it just says new text, but I can set it to hello world. And this is kind of a cheating way of saying hello world to the user, because we didn't do it to a script, but we'll get to that in a moment. Here you have all these different settings for the text. We also have alignments, which you can play around with and see which settings you like best. Okay, I'm satisfied with this, but currently I will change. Let me just set the color to something bright, like that. I will change the text to be, or maybe placeholder for now. And I'm going to save this. Oops. Yeah, let's go ahead and save our scene. I'm going to create a new folder called scenes, and I'm just going to press Ctrl S, or you can go to File and Save Scene. But I'm just used to pressing Ctrl S, and I'm going to go to Scenes and save this as _main. You can save it as whatever you want. And now you can see our scene has a different name, and we can find it in our scenes folder. Now that we have our text in our canvas, let's go ahead and navigate to our script, our testing script, and we can get a reference to this text by saying public. Actually, well, you would say public text, but you can see that I'm not getting any. The Visual Studio doesn't recognize this text as a variable type or component. That's because we need to implement a library. You can see as we have these using tags here, and this allows us to use all sorts of methods and functions. So I'm going to go ahead and say using Unity engine.ui. Now this will allow us to get references to images, text, basically anything that is contained in the UI. So I can say public text, and I can call this text. Okay, and now when the game starts, I can, well, first we need to go to Unity, select our cube. Now you see our test script component, has a text field, and it requires a text. So let's go ahead and drag this text into this. Okay. Now back in our script, when the game starts, I can say text is equal to name. So basically what this will do when the game starts, it will take this text field, so this text field, and it will go to this text here and replace it with the contents of name, which is our parameter here, which is hello world. So now if I start the game, we should get a hello world message. And there we go. So thank you for watching. In the next lecture we'll be creating kind of a watch and countdown timers, things like that, so I'll see you then. Hello and welcome back. So last time we created a script that we placed on our cube game object, and it has a public name which we can change, it's a string. Then it has a text, which is the text on the canvas, this one. It currently says placeholder, but if I run the game it will say hello world. And we also get in the console a debug log saying hello world. So today what I want to do is create a countdown timer. Let's go ahead and open our script. And in here I'm going to create a public float timer. A float is basically it can be a real number, so it can be 1.25, whereas an integer can only be 1, 2, 3, 4, 5, 6, and such numbers. Don't worry if it's confusing, we will get to this in a later lecture. We will explain this in depth in later lectures, but for now we will be creating a timer. So now, since this is declared as public, I can go ahead and go to Unity, and on my cube game object we now have a timer value, and I can also drag it here, or I can just type in maybe 10.5. In our start method we want to somehow display this timer, but we can't say text equals timer. If I say now, you can see that we were getting an error because this is a text, so it expects to get strings, it expects other text, but we're giving it numbers, so it's confused. So we could say timer.toString, which converts the number to a string. So basically, if the number was 10, it will become a string like this. So we don't need the name anymore, so let's delete that, and also delete the debug log from the update method. And let's save this and go back into Unity, see if this works. So now our name should disappear and our timer is there. If I run the game, we get 10.5. But we want to somehow subtract the timer each frame, and each frame we want to get the result here. There are many different ways you can create timers. Enumerators are one way to create timers. We will get to enumerators in a later lecture, but today I'm going to show you one I really like. So it goes like this. It's basically timer minus equal time.delta time. Now minus equal basically means is the same as timer equals timer minus time.delta time. So this statement is the same as this one. It's just that the one below is much shorter and much easier to read. So what is time.delta time? Let me just comment this out and I will demonstrate to you. It's debug.log. I will debug.log it. Time.delta time is the amount of time passed since the last frame was drawn. So basically, if on my PC the game is running at 60 FPS and on yours it's running at 30 FPS, with time.delta time we would both have the same experience in playing. But if we didn't use time.delta time, in my case it would be twice as fast than on your PC. Don't worry, this can be pretty complicated to understand, but with time, when you use it a lot, you will understand precisely how it works and how useful it is. So let me just run now and you will see what I'm talking about. You can see it's a really small number. The time passed from the last frame. Now if I stop playing and if we, let's just delete this debug log and uncomment this. So now each frame we will be subtracting the timer, but we also need to write it to the text. So let's say text.text equals timer to string. So now if I save this and go back into Unity, let me just clear the console and I run, you can see that we have a timer, but we have a lot of numbers here after 5. That's because we're using a float and these numbers really want to be precise, but there's a really easy fix for this. So when we convert our number to a string in here, we can set a formatter. So we can say, we can put these two semicolons. What are they called? Parentheses, yes. And then a hashtag 0.00. So this is how we want to format this number. So we want two numbers to be two numbers to be displayed. So now if I run, we can see we have the first number and then after that 2 numbers. Now we have a really nice countdown timer. And you can see how precise it is. No matter on what machine you run it, it will be as precise as here. There's currently a problem. It can go under 0, which I think shouldn't be happening. You can see now it goes into the minus. This shouldn't be happening. Usually when timers hit 0, they stop. So we can fix that really easily. We can say, we can add an if statement here. So basically what an if statement does is it checks to see if a condition is true. So basically I can say if timer is less than or equal to 0, I want to do this. Let me just put these. You can see these curly brackets, they indicate which code is part of what. So basically you can see update. All that is inside of here will be executed each frame. So each frame we are checking if timer is less than or equal to 0, and then we want to do something. We actually want to check if we want to see if it's greater than or equal to 0, we want to subtract it. And then we can say, so if this isn't true, when timer is less than or equal to 0, we can say else, else, and then just say text.text becomes 0.0. Now if I save this and go back into Unity, I can run the game and we should see our countdown timer working properly and it should stop at 0. Let's see if I am right. And there you go, it stops at 0. You can also increase the value of our timer and it will work just as fine. So now I set it to 50 and you can see how it works perfectly. So thank you for watching. Next time we will be displaying a digital clock. Until then, I bid you farewell. Hello and welcome back. So last time we created a countdown timer, so we can just write in a number here in our components tab, and the number will count down from that number to 0. Once it hits 0, the countdown stops. What I want us to do today is create a clock, a watch. So basically we will take the system time here and just display it in the game. So currently it's 5:28 p.m. So let's go ahead, and to do this we need to implement a library. We're going to say using system. So just using system, your system, which allows us to get the time and similar things like microphone, etc. So when the game starts, actually in the update, let's go ahead and create a new variable of type datetime. You can call it current time, and in here we're going to say datetime.now. So each frame we will get the current time and just put it inside of this variable. Since you know time is constantly moving forward, minutes are passing, seconds are passing, we need to get all of that each time. I'm going to remove our timer logic. I don't want our timer anymore. So let's just delete all of this. Okay, so now we have our current time here. So what we can do now is create a new string called hour. Actually, we can create it up here. Why not? Let's do that for minute and for second. And now we can say hour equals to current time dot hour to string. So now we took our current time and we took the hour that currently is, and we converted it to string and put it inside hour. So I can now say text equals hour, and I should get instead of placeholder 5. So now if I run the game, and I get 17, which is military, but that's pretty much 5. Okay, so that works great. So let's go ahead and do the exact same thing for everything else. So let's say minute equals current time dot minute and convert that to string. And let's get seconds. Second equals current time dot minute dot actual second to string. Okay, but now how will we have three separate strings. How are we going to display all of them? Well, we can just simply say hour plus minute plus second. This will just add each string to the other. So now if I run the game, we get 70, 31 and 8 seconds, 9, 10 seconds. Now this is really hard to read. One would think it's some kind of code. He wouldn't think, oh, it's a time. So let's go ahead and go back to our script, and we can say plus, our plus, and we can put in these semicolons, and then this how is it called? I forgot, sorry. And plus again that. Now we should have a nice and easy to read clock. And there we go, 17 hours, 31 minutes and 55 seconds, 6, 7, 8, 9, 10 and 32 minutes. Okay. We could do this easier. Currently it's just taking up a lot of space in the update method, so let's go ahead and create a new method called void. Let's call it create clock. We say void because currently this method doesn't return anything. We will also talk about methods more in depth in a later lecture. For now, this method won't return anything, any value. We'll just call it and it will execute code that is inside of here. So we can take all of this code now from here and just paste it down here. So now we have this method that's called create clock, and each frame, well, currently not each frame, but whenever we call it, it's going to get the current time, it's going to get the hours, minutes and seconds, and then it's going to place them in the text. We can also drop this down to have a nice preview of our code. It's nice and tidy. So now let's go ahead and go to the update method and just say create, create clock. And don't forget to put 2 parentheses here. So now if I save this script and go back into Unity, we should have the same effect as previously. And we do. But just now our script is easier to read. We can drop this down and we know what this does. It only uses up 1 line of code in the update method. We also currently don't need the start method, but let's leave it for now. So that would be it for this lecture. In the next one, we will continue our work on UI and probably working with some images. So thank you for watching and see you then.